we're going to click on motor correction. Okay. The motor correction, it's automatically going to say, hey, we're going to find the tool that you put in there. It did. That's what we're going to measure, KP25. Right? Motor correction, it's old after 90 days. Right? You can change that value to every 365 if you want, every 830, 2 years, give yourself. Usually leave it at 90 days because in 90 days you're going to get a warning, hey, your motor correction is invalid. At that time, what you can do is just come back in. You don't have to do the inertia for the motor, but I would do the inertia for the measuring system set up like this, and then I do the motor correction. It takes you about 5 minutes, then you're good to go, right? And it just keeps things current.
Why don't we have to do the inertia for the motor after 90 days?
Huh?
You said after 90 days we don't have to do the inertia for the motor.
If you think about it,
yeah.
What's really changing in the motor? Most of it's buried inside, right?
Yeah.
But the measuring system, you're going to take in and out, remove. You're going to wipe sample off of it. You're probably more likely going to change things in there. You can do the moment of inertia for the motor, but I'll bet if you do it every 90 days and just check the values, you'll see that the motor never changes.
Yeah.
The measuring system might change slightly if you look at its values, right? So by experience, we tell people, hey, there's nothing wrong with doing the motor. Practically, you don't have to do it, but maybe once a year or something. Because there shouldn't be anything if it's kept on. If you don't move the instrument, if you move the instrument, all bets are off. Redo everything, right? Okay. Now what I'm going to do is I'm going to click Start Though. This is for the motor adjustment. If you notice, because the motor adjustment's really kind of key, right? It's going to rotate around real slowly and measure the torque. When you click Start, it tells you, okay, perform the motor adjustment at 1 millimeter for this tool. Well, we're at a 1 millimeter gap, so we're good. It's also going to tell you, do it without sample, do it at the recommended position, don't interfere, don't make any bumps on the table. Opening, slamming the door puts vibration into the room. Vibration feels a torque, right? So what we want to do is just kind of leave the instrument alone, don't do anything to really jar it. What would happen then? Well, remember, it's measuring the torque at every position as it goes around, right? It's recording a value there. You do it one speed and another speed. It's going to give the average between those, right? The thing is that at that one position, maybe you'll see a spike because you've been in and out of the door. Will that affect your data? Well, hey, if you're doing a big oscillation, if you're doing rotation, maybe not. But it's that prolonged, it's just another source of error. So try to keep those as much to your minimum as you can. And what we do is I'll hit continue. Don't worry, when it says continue, it says, hey, do you want to replace the old one with the new one? And you say, okay. Now, it's going to take it probably about 3 minutes to run through. So we got 3 minutes to sit here and watch. So it starts off at 1 speed. It's going to go faster and faster. Pretty soon it'll look like it's not moving at all because it's going very fast and you can't read the words anymore on there, right? Which is what it's doing now. So at this point we don't bump the counter or lean on our stuff and we're good. Just like the other measurements, when it's done, see the screen's grayed out now, it'll come back and it'll look black. You can click OK, save it. But so right now we're kind of running through things as just, hey, how do you take care of the instrument still, right? Practically speaking, if you were going to run a sample today, right, you would do things, you wouldn't really need to do all these steps. If you're running very thin samples, say if you're doing things like water, where you're down at the low end of the torque and you're doing low speeds, it may be best to come in and do a motor correction, moment of inertia motor correction every day. Start of the day, do that first thing, and then run all day long, you're okay. If you're doing samples that are more viscoelastic, require higher torques, you're probably at a point where, if you think about it, since it's a torque sensor, you're measuring things that require torques up here. You don't really care so much about what's happening in this noise region because proportionally they're very small. If you're measuring very thin solutions or weak gels, right, you're down here at the low end of the torque, so any noise makes a big difference, right? So in general, people ask, well, how often should I do this? And I tell them, hey, it really depends on your materials. Looking at what Dr. Bardet has here, you have not necessarily very thick, especially if they're higher temperatures, but there's certainly things that don't require, say, the level of sensitivity of the water, right? So you may be okay, just do your motor adjustments once every 3 months. That should be good. Okay, so we just finished up running. I'll go ahead and click OK. And that's done, right? Now, the head is down, the measuring system at the measuring position. One thing I might want to do when I run these is check it, right? How can I check it? Well, let's just say we want to run an air. And we want to look at what all the little torques are when we run an air. There's a template, and I'll get to that in a little bit, called Air Check. I'm going to go ahead and click OK to get out of Control Panel. One thing I noticed is that Air Check at installation, this looks like, oh yeah. So this is the air check we ran when we installed the system. And what you can see here is that it reads, hey, all the values of torque as it moves around 720 degrees, a little bit more, 730, so a little more than 2 rotations, right? At a fairly slow speed, and all it's doing is measuring torque. In rotational mode, we say the torque limit, hey, it's good if it's within 0.05, right? Micronewton meters, right? So in this case, this is what I was saying. It's a template. This one's already been run, and it has a couple different air checks in it. I'm just going to hit run again to add the third one. And it's telling me, hey, do you want to run with what you currently say you have on here? And I'm going to say, yeah. Cool. Check to see if cooling water is flowing, Yeah, cooling water is flowing. I think what we have to do here. Because in this template, we never set the gap, so we hit 0 gap. Okay. 0 gap. Template, click OK. Okay. We may not have had it on for long enough, obviously, because everything was shut off. That's the other thing you can tell is that when you flip it on and you do this, you usually want it to be on at least an hour with the air and everything in it before it runs. It turned up. We try it again in another couple hours, it will be really good.
Okay.
So again, if you think, hey, it's real sensitive to what it's measuring, part of that is temperature, the electronic. It's a little noisy, but for our purposes to train today, I think we're good to go at this point. So what we'll do is run some samples. At the end of the day, we can redo the inertia and motor correction, and you can see how much it improved.
Okay.
That might be a good way to start, because then that way we get our things accomplished. Raise it up. Okay, so I just put it in a lift position and went up to lift position. Okay.